Okay, good morning. So, I'm sure you guys were not sad with the experimental delta math quiz yesterday. Did not behave as it was supposed to. Don't worry, I'm figuring it out. It will be better next time, meaning not all 3 points, which is why it is not 20 points, it's 15, because it didn't deduct anything because it didn't let you go negative. So if you got one wrong, it was like, oh, we'll start off at 0, and then you got the next one right. I said, well, that's not what I intended. So anyway, those scores are in there. We do have one more thing, and it's a group presentation project, poster, something, write-up tomorrow. And to prepare you for those, what those problems are, you actually already have the sheet, but I need to teach you the stuff. Well, you can just hold that thought then. Let's have a look here. Okay. The luck, man, the luck. All right, so according to students, this is one of the more dreaded concepts. I think it's cool and awesome that it's hands-on, it's applicable. It is one of the most lucrative, possible things. Alex, you're in here. So, yeah, lots of business uses. So for example, you have 40 feet of fence to enclose a rectangular garden, and you're gonna put up one side against the barn. You need to fence the barn. Like, you don't need fencing on that wall. Okay, so a lot of you know, like, okay, if it's a 4-sided figure, optimally, the most area is in a square. But that you get one side for free, how do we do this? So this is an optimization question. So, to do this, what are we given? What information do we know? Right? What is one thing we can get out of this? What they're telling us.
Two sides will be the same and one side will be different.
Okay, 2 sides are going to be the same. What do we want to label them? X, Y, W, L? What do you want to name them? Right? You pick. H and L. Okay. So what else do we know from what's been told? Naomi, you were going to say something?
I guess the perimeter would be like L on the other side, and then it would, I guess the 3 sides of the would be.
Okay, so she's saying the perimeter that we know, we have 40 feet of fence, so all the edges need to add up to 40, which is 2 H's and 1 L. Okay. What do we want to have maximized or minimized? The area of what? A rectangle, okay. It's not that hard, guys. What's the area formula for a rectangle? Okay, so despite that the students from the past are like, oh my God, it's so hard. It's not that hard, people. Area of a rectangle, base times height, length times width, H times L. Okay. We are single variable calculus. I have multiple variables here. I need to figure out a way to make a relationship between those two variables. Hence the reason I have two equations. Naomi told us this one. Mayan, you can pick. Should we solve for H or should we solve for L? It doesn't matter. H. Okay, solving for H. Good? So Franco, I want my area all with one letter, so what do I need to do? Area, what is happening? Area of a rectangle, height times length, yeah?
Yeah.
Right here? I want all one letter, I don't want H and L, I want just H's or just L's. Mayan did something for us, what should we do with it?
I don't understand the question.
I want area, all in terms of one variable, not two. So substitute, get rid of H and put in what we calculated for H. 40 minus L over 2 times L. Okay, now do I have area all in one variable? Okay. How do we find maxes and mins of something? Do the derivative. So we have the choice. Do we want to multiply this out first? Glenn, you pick. Do we multiply it out first or do we just do product?
Multiply that.
Multiply it out first, okay. 40 divided by 2 is 20 times L minus L squared over 2. Gotta say, Ray, I'm not digging the L's, because my L's, I have to make them stupid looking so they don't look like ones in problems. And now it looks like an E. Apologize for my handwriting. Okay, so we still didn't do the derivative. Kari, how do I derivatize?
You multiply that power over time, so d over dl equals 20 minus 2l. Oh wait, no, never mind. Just l. Yeah.
Just L. So like minus 2L divided by 2, oh wait, just L. Yeah, just L. Adrian, what are the critical points? Where is it undefined? Okay, it's undefined nowhere, but where is it 0 at 20? Oh, and I always forget. Woo. In context of the question, are there any restrictions? So can H be negative? No. So H has to be bigger than 0. What's the smallest? Yeah.
I just have a question. Does it say there's like a limit for the barn? Is there a limit?
So we're assuming the barn is bigger than the length of our fence. But H, what's the biggest that H could be? By the way this is marked, what's the biggest that H could be? 40? 20. So I have 2 H's. And, you know, if it's for, you know, your dog to run around in, it's a long, skinny, flat, not useful thing. And then restrictions on L, if we staple the fence to the wall of the barn, it's not very helpful either. But that would be 0 to 40. These are the restrictions. So, all right. Adrian says our one and only critical point is 20. And in these problems, I really, really, really want you to say what the derivative is. Don't give me a prime, don't give me x prime, y prime, whatever. Tell me, how is the area changing as we change the length? That's what it means. All right, checking a number like 10, 20 minus 10, that's positive. Checking a number like 30, I get a negative. So is this, George, is L equals 20, is that a maximum or a minimum, and why?
It's a maximum because it's, there's not, because
What is it?
the graph, the graph.
I have no graph.
The line, the derivative.
Because dA dL went from positive to negative. That's the reasoning. The derivative, what derivative? dA dL. The change in the area as we change the length was going up and up and up. So we hit 20 and then it started to get lower. So we're gonna have a maximum what? Maximum area when L is 20 feet. What did the problem say? Did I answer the question? Amelia, what do I need to do? Do what?
Like, you already found it out.
So, okay, so, oh, I thought you said 8. I'm like, what's 8? So I need to find H, okay, what is H? How do we find H? Sebastian, how do you get
What?
to?
Oh, you just go to the perimeter equation and plug in for L.
So go to the perimeter equation, plug in for L, 2H equals 40, so H equals 10. I still didn't answer the question. Cameron?
It's asking for area, so you just change it.
So it's asking for area, so 200. And in these problems, you need your units. It's not feet cubed, area is feet squared. So these aren't hard, but there are so many details to pay attention to. There's the process, right? Lots of words, so sorry. It's easier to do these than write them down. So first thing, read the problem. Second question, or step, really read the problem. Identify all the information, pull everything out. And then make some kind of mathematical model. Were we asking you to find area? Were we giving you perimeter? Were we talking about volume? What did we give you? And again, single variable calculus. They're gonna give you something like the perimeter in the last problem that Naomi gave us, so that we can then plug it into the area which we wanted to maximize or minimize. So figure out that function, whatever it is, could be Pythagorean theorem. Do the derivative, find the critical points and test them. You also need to think about the restrictions of the real world thing, like, can you have negative length? No. When we cut the corners out of the paper, could we have cut a 6-inch corner out of an 8.5 by 11 paper? No. 6 inches is more than half. Then solve your model and interpret your answer. So let's try this. How many of you have siblings at Cornell? No one? Okay. Cornell, Barton Hall, it's the gym. It's shaped like this, and they want to have as much overhead space so that you can play sort of volleyball, baseball, things like that within, because Cornell, we get a lot of snow, and also the snow rolls off better and doesn't make the roof collapse when it's round. Anyway, so how do you get the most space so that you can have a quarter-mile track inside on the ski part? So the question says, a rectangle is inscribed under an arch of a sine curve. What's the largest area that we can have? Okay, what are we trying to maximize? Area of what shape? Okay, good. What's the area formula of a rectangle again? Length times width? Okay, okay. equation of the arch? It says sine. The arch. Jason, if, how do I find coordinate for P? Yeah, this coordinate P, it's where the rectangle hits the sine curve. Like, okay. Before we start, are there any restrictions, like, I'm gonna call this thing X. How big can X be? Can X be 5? Can X be pi? Can X be, yeah,
It has to be less than pi over 2. Or you're talking about just one side, or?
okay, okay. I agree with you. X has to be less than pi over 2. Why didn't he say pi? Like, why couldn't X come all the way out here? If you go all the way out there, you basically cut the whole paper in half. Like, X at most can be pi over 2. Okay? If the X value is, just X, what's the Y value where it hits that curve? Thank you. The Y value is sine of X. So what is the height there? The height is that Y value. Okay. Oops, length times. Should be consistent in my naming. Now I need that guy. What is L? Two people think they have an idea. We've been talking a lot though. Anyone else got ideas? Alex?
Is it pi minus 2x?
There's a symmetry to it. That distance, X, it's gonna be that same one. So length is pi minus 2x. Okay. So you guys need a calculator. Do the derivative, find your critical points. I'm gonna ask you guys to write down what the derivative is. You can't really see from there, and it's all wrong. those who should be writing on the board. Julia, Kari, Christy, Kathy, George, Franco, Evan, Ray, Nathaniel, Sita, and Flynn.
Oh, wait, and then you just want to.
Who are you guys missing? At least he told me he was gonna be out. He's too good at golf.
Okay, so you don't have a number, at least write down the derivative on the whiteboard so I can see what you guys get.
We need to solve for problem.
I got it.
Okay. Looks like
Wait, when you multiply these out, is it like,
that.
yeah, I think.
You guys get an answer? That's right.
Thanks for your knowledge.
Rohit, would you guys get as a derivative?
I minus 2x plus n of x minus 2x.
So you said pi minus 2x times cosine x, then what?
Minus 2 sin x.
Where is it undefined? Nowhere. And then, on your graphing calculator, those of you who are using that, I would set the window to 0 to pi over 2. Because Michael said in the beginning, it can't even be pi, it had to be half of that full distance. One arch of a sine curve goes to pi, so zoom in 0 to pi over 2. And again, is maximized at pi over 4, which I don't expect you guys to know. So some decimal answers, 3 decimals. People kept that last 0, which is what we want. Did I verify that it's a maximum or a minimum? No. Okay, Kyle, what do I need to do to maximize?
Number line.
Okay, number line, how am I gonna label the number line?
Put your restrictions and points that means here.
Okay, 0, pi over 4, pi over 2, but still I don't have a name on it. What's the name?
dA over dx.
dA over dx. And the reason I'm like stressing that you guys, I want you to know what you're checking. Checking how does the area change as x changes. What am I plugging the numbers into? That derivative. So I saw the graph. I'm not gonna pick numbers, I saw the graph. The graph of the derivative was positive there, and then it went negative. So Sadie, what do I know because the derivative went from positive to negative?
Oh, it's not.
So it's a maximum area when x equals pi over 4. Julia, why? What's the,
Because, what?
what's my reasoning here?
Because it's first positive at
Just use
negative.
0 to.
No, it. So, no it's, you gotta tell me what went positive to negative. Don't tell me the graph changed or crossed over the x-axis, there is no graph given. And even if you draw your own graph, AP doesn't take it. Evan?
The area with respect to the x.
Okay, did we find all the answers? It says, what is the area of the largest rectangle? Did we find that? No, so we need to do that. And it says, what are the dimensions? So, I didn't actually find anything. What's the length, what is the height, what is the area? Don't know? Typey. Here's an equation for area. Length, width, find them. The width is easy. Because pi over 4. So flare, the x value was pi over 4. So what is the length? Pi over 2. The height or the width? Height is this dimension. Nathaniel, what is this dimension? Root 2 over 2. Sine of pi over 4. So what is the area? Length times height. Root 2 times pi over 4. People that got decimals, what did we get? Anyone get that? Katie's working on it. Katie, what did you get? 1.122, just one corroboration on both sides of the room, which means everybody else in the middle, you gotta agree.
Wait, how'd you before?
Okay, how did I get it?
Okay.
I looked at the derivative and it gave, Desmos is giving me the nice answer. On your calculator, 0.710, but that is, as pi over 4, it's easier to do by hand. Okay. Here's the simplest of the simple. Another optimization question. Y equals 4x minus 2. I want to find the minimum product. I don't know, P for product. Zach, how do I find an equation for the product x times y? I want it all just as one letter. of a trick question. Like in the last thing we had, the very first one, we had perimeter with length and width, and we had to solve and swap out one for the other. I have an X and I have a Y.
Oh, you just have y equal to the parts minus two.
So instead of Y, I'm gonna take what Y equals. Yes. That's the equation that you want to maximize or minimize. See, which one are we doing in this case? Okay, so do that.
Cause I think I got it.
Okay. Okay. Yep. Cameron?
On the last problem.
Yeah, that, you got 0.710 and that's
Yeah.
not 0.785. That's what, Michael was just saying. So, I need to think about that, I'll get back to you. Evidently Desmos is wrong, or I typed it wrong. Cause I believe I have the solution as 0.710, which is not pi over 4. It's close, but not it. Ella, how do I find the maximum or minimum of something? Do the derivative, okay. So, here's the function I want to minimize, do the derivative.
8x minus
How did you get 8x?
2. Cause I did 4x squared minus 2x.
So you multiplied out first
Yeah.
and then you did the derivative,
Yeah.
okay? Totally your choice. She said, I'm gonna do a little algebra first before I do the derivative because I like power rule better than product rule. Cool, do it. So then, Katie, what do I do from here?
You solve for x. So x equals 1/4.
All right. So what we're looking for are the critical points. Where is it undefined? Nowhere. Where is it 0? 1/4. Okay. Jason, what do I do with that critical point? Do I immediately assume that that's the minimum? Because I need an answer?
You make a little graph.
Make a number line. And name it. So Abby, testing my derivative, which is right here, or actually really right here, at 0, is it positive or negative? Negative. And Ola, testing at like 9,000, is it positive or negative? Positive. So it said find the minimum product. And this is what I just found. Did I get the answer to the question? Now, Evan, what am I still gonna do?
Solve for y and then multiply.
Solve for y and then multiply. So actually solving the question, you gotta read the question. So Roman, how do I solve for y?
You put x into the original equation.
Okay, the original equation right here, this one? Okay, so what is y?
-1.
So then Christie, what is my product?
It's -1.
Okay? How's it feel?
Good.
Optimization horrible means scary? Okay. One more problem.
Solha. Oh,
The AP exam will never give you any formulas ever except 3D volumes. So in a question like this, and they'll say, oh, but of course you recall the volume of a cylinder is pi r squared h, or a cone is 1/3 pi r squared h times, yeah, 1/3 pi r squared h. They'll give you volume. That's all they ever give you. So, that's all I'm gonna give you. What are we trying to minimize? Surface area? Yeah. So in business, the way they'll say these things, you know, we wanna minimize cost, really. And if any of you have gotten, water bottles, plastic water bottles, they are definitely skimping on the material. Those little plastic bottles are so thin and flimsy now, they puncture and, so they wanna minimize the material by minimizing the area of the container. They do not give you area formulas ever. We did talk about one of these the other day, though. What's the surface area of, I'm assuming the can has a top to it, because we don't want the oil to reflow. What's the surface area of the cylinder? Okay, I will pick on one of the speakers.
Naomi.
So.
No, sorry, pi r squared plus 2 pi r.
Pi r squared is the area of the bottom, plus, so if we curl up a piece of paper, she said the circumference, 2 pi r, and then when we cut it open, h, I need a lid, so I have 2 circles. But Sebastian, I got the problem that the thing I want to do the derivative of, the surface area, the thing I want to minimize, has an R and an H, and they vary. What can I do?
Like in terms of like setting up the equation?
Yeah,
Like
I need to
factor
get
out?
all in one letter.
So, like factoring out?
No, I need, I either need to get rid of R or I need to get rid of H. Do I know what my volume is?
Pi r squared h? Oh, 1 liter.
1 liter. Volume is 1 liter. So again, this is like the barn problem in the beginning. Like Naomi had the breakthrough and was like, hey, I know perimeter. I have 2 equations, 2 unknowns. Let's see. Cameron, you can pick. Should I solve for R or solve for H in the volume? H is probably a nicer thing. Plug Claudia, how does that help me?
You can have the same, like, variable, like, for the
Okay, so Franco, same question as before. I want all this to be R's instead of R's and H's. How do I get rid of the H's?
Plug it in whenever pi r squared.
So put that in instead of H. Okay, so 2 pi r squared plus 2 pi r times 1 over pi r squared. Okay. Do that derivative, see what you get. You guys, reporters, can you write the derivative you got on the whiteboard?
Yeah, I got it.
Derivative surfaces pi r.
See? Okay, need a label on it. Okay. Some of you rearranged these, and wrote the -2, missing a squared in the bottom. So multiply by the power, lower the power, we get 4 pi r. Multiply by the power here, the thing I'm mostly worried about is that you guys lose the negative. Context of the question, can I have a negative radius? Can I have a 0 radius? No, so, I do get a critical point of r equals 0. So that is one constraint. Should have put these in the first place, so sorry, I do always forget that. So the radius has to be bigger than 0, and I need to have some height to this can. Critical point so far is 0, r is 0. Roman, how do I find any other critical points? How do I find critical points? Okay, what do I do with the derivative? Well, perhaps this is an uncalculated question. What do I do?
Then set it equal to 0 and solve for r.
Okay. How do I do that?
You do the 2 over r squared over, and then multiply by r squared.
Okay. So tonight's homework, please do day 37 out of the textbook. It's a stinker. Tomorrow, you guys had a worksheet with problems on it. You will be given one of these problems tomorrow in your group to put up and write up and turn in, like as a group, you turn in one sheet of paper. Be prepared, try tonight's homework for the test.